Ever wonder how the world agrees on something as precise as a single second, or how a clock actually knows that time is passing at all? Today on Knowledge Hub, we're breaking down how time is calculated, how the second was defined, and how different types of clocks and watches actually measure the passage of time. Starting with the fact that timekeeping is fundamentally about counting stable, repeating events. Long before clocks existed, early civilizations relied on astronomy, watching the sun's shadow move across the ground or tracking the motion of stars, and ancient Babylonians adopted a base 60 number system because it was mathematically convenient, allowing easy division into halves, thirds, quarters, and sixths, which is why a full day was eventually split into 24 hours, each hour into 60 minutes, and each minute into 60 smaller parts. For centuries, a second was defined as 1/86,400th of a mean solar day, but as measurement tools improved, scientists discovered Earth's rotation is not perfectly constant. It slows slightly due to tidal friction and fluctuates due to geological and atmospheric effects, meaning time based purely on Earth's motion would slowly drift. Mechanical clocks attempted to solve this by using oscillators, like pendulums or balance wheels, where energy from a wound spring is released in controlled steps by an escapement mechanism, each swing representing a fixed fraction of time, while gears repeatedly divide that motion into seconds, minutes, and hours. Automatic watches work on the same principle, but instead of manual winding, a rotating mass called a rotor spins with the motion of your wrist, continuously winding the mainspring and keeping the balanced wheel oscillating at a steady frequency, typically several beats per second. Quartz clocks replaced moving oscillators with physics, using the piezoelectric effect of quartz crystals, where applying voltage makes the crystal vibrate at an extremely stable frequency of 32,768 times per second. And electronic circuits count and divide these vibrations down into 1-second pulses, making quartz watches far more accurate and resistant to environmental changes. Digital clocks use the same quartz oscillator internally, but instead of moving hands, microcontrollers count electrical pulses and drive LED, LCD, or OLED displays to show time numerically. The clock in your phone goes even further, still using an internal quartz oscillator for short-term timing, but constantly synchronizing itself with network time servers and GPS signals that ultimately trace back to atomic clocks, ensuring your phone stays accurate even if its internal oscillator drifts. Atomic clocks represent the most precise timekeeping humans have ever achieved, defining the second as exactly 9,192,631,770 oscillations of radiation produced by a specific energy transition in cesium-133 atoms, a definition maintained globally by organizations like Bureau International des Poids Measures, allowing every country, satellite, financial system, and communication network to agree on the same second. From this atomic definition, minutes and hours are no longer measured directly at all. They are simply counted. 60 atomic seconds form a minute, 60 minutes form an hour, and leap seconds are occasionally added to keep atomic time aligned with Earth's slowing rotation. So whether it's gears releasing energy, crystals vibrating under voltage, software counting pulses, or atoms flipping quantum states, every clock is doing the same essential job, counting an incredibly regular event and agreeing that a specific number of repetitions equals 1 second. If you have enjoyed this deep dive into how time is measured and kept in sync across the planet, make sure you subscribe to Knowledge Hub for more explanations about the hidden systems that run our world. And as always, stay curious.